Interesting question about a diode that's in forward bias, and we're asked to use the precise method, that means the diode equation, to find both the current passing through the diode and the potential difference across the diode, or the diode voltage, right? So the only way to do this will be iteratively, or let's say a practical way to do this would be iteratively. So we're given some information, we're given the current at a voltage of 0.7 volts, we're given room temperature, we're given the potential difference in the circuit is 6 volts, the ideality factor of 2, and the value of our resistor is 100 ohms. So even though there are just two equations, it's actually quite a lot of work. So if we look at these equations, there's quite a lot going on. So let's look at this. We have ID, that's what we're trying to find. But VT, the thermal voltage, we don't have that. We're going to have to calculate that. VD, that's what we're trying to find as well. So we're going to have to try to maybe guess ID and then find VD and then put that back in there. So it looks like it's going to be an iterative process. So you make a guess for ID and then use that guess to find VD and then keep doing that. So once you've got VD, you can then get a better guess for ID. So before we start on that, let's rearrange all of these equations. And even before that, let's find the thermal voltage, VT. So VT, sometimes it's given to you, but the actual equation to find it is the Boltzmann constant K multiplied by the temperature in Kelvin divided by the charge of an electron. So that will give you, in this question, the temperature is given as 300. That's the Boltzmann constant K, and that's the charge of the electron E. So that gives you 0.0258, or 26 millivolts is the standard value we often use. So that's the value of VT. So that will be used there. I also want to rearrange this to find VD. So bear with me a second. If I want to rearrange the diode equation to find VD, you would want to divide both sides by I0 and then add 1 to both sides. Then take the natural log of both sides, then multiply by eta VT. Okay, so eta is given in the question, and VT we now know to be 0.02588. Okay, so we're going to need that equation. Let's also rearrange the other equation to find ID. So you would subtract VD from both sides and then divide by R. That will give you an equation for ID. So basically, we're rearranging both of these equations to get the two things that we need. Okay, the final thing I want to do is find the value for the saturation current I0. So I'm going to rearrange the same equation again, but this time not to find VD, but to find I0. So if you divide both sides by this expression in brackets, that gives you an expression for I0. But now we can use the value given in the question, 1 milliamp, here. So let me just label that. That is 1 milliamp, and in this case we're given in the question 0.7 volts, and VT is 0.02588, and eta is 2. So if you put all that in a calculator, we end up with the saturation current of 1.3 nanoamperes. Okay, so that's our value for I naught. So now with all that information, we can start on our process. So the first thing we need to do is take a guess for ID. And the best guess for ID, I guess, would be by putting 0.7 in there. So it's V minus VD over R. So I would say a good guess for ID would be 6 minus 0.7 over 100 ohms. I'm going to write 0.1 kilo ohm. So I get my results in milliampere, so 53 milliamps. That's my first guess, right? It's probably not a very good guess, but it's not too far off because it isn't unreasonable to expect VD to be around 0.7. So that's my 53. Now, using that, I'm going to try to find VD. I'm going to use ID as 53 milliamps. I naught, we've already found. That's the 1.3 picoamps. We just found that up there. Eta is given in the question, the ideality factor of 2. VT is the 26 millivolts, or 0.0. Okay, that's there. That's our VT, thermal voltage. So now everything in this equation is given except ID. ID, that we're going to use our guess. And if we put that in a calculator, we get 0.907 volts. So that's our working guess for VD based on an estimate of ID. We can now refine our guess for ID by putting VD back into the equation for ID. So now we can say 6 minus 0.907 divided by 0.1 in this case, it'll give me 50.93. So my ID started off at 53 milliamps. Now we think it's 50.93 milliamps. So the error, the difference between our guess and our calculation is 2 milliamps. So it's about 4%. So 2 milliamps error. So we're still not too happy about that. So we can probably improve our estimate even better. So now our guess can be the 53 that we just found. So we can put this, sorry, the 50.93. So now instead of 53, we can put 50.9 as our guess. Now, if we put that back into the expression that we just used, we'll get an even better approximation for VD. So I'm just putting all the same numbers, but I'm going to replace the 53 with 50.9. And this time it's given me 0.904 volts. So a very slight change, but I'm now going to put that in there to see if we get an even better estimate for ID. 6 minus 0.904 divided by 0.1 gives me 50.96 milliamps. And now my error is, it's still in the order of 2 milliamps, so the error isn't really reducing very much. So we could keep going around this cycle indefinitely, but I think we've gone round twice and we've got to 50.96, and the error doesn't look like it's changing much, and it's in the order of 4%. And if we're happy with that, then we can consider that to be our final answer. So the question asked for the voltage and current, and we can say the current is in the order of 50.96 and the voltage 0.904. So I hope you found that helpful.